Good morning, students. Today we are going to discuss about 1 marks for fifth lesson. Okay, students, fifth lesson theoretical side is already over, right? So today we are going to discuss their 1 marks. Okay, students. Okay, right. First question, choose the correct answer. First question, when a sound wave travels through the air particles, when the sound wave travels through air, then the air particles, which is correct. See the first option, vibrate along the direction of the wave motion. Vibrate along the direction of wave motion. And second one is vibrate but not in any fixed direction. Vibrate but not in any fixed direction. And third option, vibrate perpendicular to the direction of wave motion. So vibrate perpendicular to the direction of the wave motion. And the last option, do not vibrate. So based on this 4 option, which is correct? First one is correct, because the sound wave travel through air, the particles are vibrate along the direction of the wave motion. Yes, so which is correct? The option A is correct. So the right answer is option A, vibrate along the direction of the wave motion. Okay, students, right. Next question. See the next question. Velocity of sound in a gaseous medium is 330 meter per second. The velocity of sound in a gaseous medium is 330 meter per second. Okay. Now, if the pressure is increased by 4 times, if the pressure is increased by 4 times without what? Without causing a change in the temperature, and the velocity of sound in the gases is, so velocity of sound in the gas, we have to find out velocity of the sound in gas. How to find out the answer? Okay, and see the answer. First one is 330 meter per second, second one is 660 meter per second, and option C is 156 meter per second, and option D is 990 meter per second. So what is that answer? What is the answer? Option A is the answer, right answer, 330 meter per second, because the velocity of sound is independent of pressure. The reason is the velocity of sound is independent of the pressure. Independent of pressure, not dependent. That's why the velocity of sound in the gaseous medium already given, no, 330 meter per second. Therefore, the velocity of sound in the gas is also 330 meter per second, because the velocity of sound is independent of pressure. Independent of pressure. Okay, students? Right. So the answer is 330 meter per second. Okay, students? Right? Okay. The next question is, the frequency which is audible to the human ear. The frequency which is audible to the human ear is, see the options, 50 kilohertz, 20 kilohertz, 15,000 kilohertz, 10,000 kilohertz, right? So which is correct? Which is correct? So audible frequency obviously 20 kilohertz. So the answer is 20 kilohertz because the audible range is 20 hertz to 20,000 hertz. So 1000 is nothing but kilo, therefore 20 kilohertz. Which one? 20 kilohertz. So B is the answer. Okay, students, right. Next, fourth question. See the question. The velocity of sound in air at a particular temperature is 330 meter per second. Velocity of sound in air at a particular temperature is 330 meter per second. So what will be its value when the temperature is doubled and the pressure is halved? See the question. What will be its value when the temperature is doubled and the pressure is halved? So which is the right answer? See the options. First one is 330 meter per second, and option B is 165 meter per second. Option C is 330 into root 2 meter per second, and option D is 320 divided by root 2 meter per second. So here, when the velocity is directly proportional to the square root of its temperature. So the hint is the velocity is always directly proportional to the square root of its temperature. Therefore, yes, when the temperature is doubled, yes, therefore what is the answer? See, this is the answer. Velocity is directly proportional to square root of its temperature, right? Velocity is directly proportional to square root of its temperature. From this concept, I am taking here the temperature is doubled, therefore 330 is velocity into what will come? Root 2 ms power minus 1. ms power minus 1. 330 into root 2 ms power minus 1. This is that right answer. Okay, students, right? Okay, and the next, fifth one. If a sound wave travels with the frequency of 1.25 into 10 power 4 hertz, 1.25 into 10 power 4 hertz at 344 meter per second, then the wavelength will be, so what is the wavelength? Options are 27.52 meter and 275.2 meter, 0.02752 meter and 2.752 meter. So we have to find out the wavelength. So what is the formula? See the solution. If velocity which is equal to n into lambda, n is the frequency, lambda is the what? Wavelength. Therefore n is given 1.25 into 10 power 4. So that is C. The frequency in the question is given 1.25 into 10 power 4 hertz, and that velocity 344. Therefore n is 1.25 into 10 power 4 and V is 344. So from this formula I am taking lambda which is equal to V by n. So what is V? 344 divided by n, 1.25 into 10 power 4. Therefore, if I am taking 10 power 4, go to this side, 344 divided by 12,500. Therefore, if I simplify 344 divided by 12,500, I can get lambda is equal to 0.02752 meter. So, which is the right answer? Option C is the right answer. Which is the option C, 0.02752 meter. This is the right answer. Okay, students. So, which is the right answer? C is the right answer. Okay, right? Okay. Next, sixth question, theoretical question. The sound waves are reflected from an obstacles into the same medium from which they were incident, and which of the following changes? Read the question. The sound waves are reflected from an obstacle into the same medium from which they were incident, and which of the following changes? Which of the following changes? So what will changes? Speed, frequency, wavelength, and none of this. So which is the right answer? Option D is the right answer. None of these. Which is the right answer? None of these. Okay, students. Right? Okay. Next question. Seventh question. Velocity of sound in the atmosphere of a planet is 500 meters per second. So this is the velocity v. The minimum distance between the sources of sound and obstacles to hear and the echo should be. Options are 17 meter, 20 meter, 25 meter, 50 meter. So which is the right answer? Right? And see the solution. V which is equal to 500 meter per second. Right? So I'm taking the formula. Yes, D is equal to V by 20. V divided by 20. So what is V value here? 500. Therefore 500 divided by 20, I can get 25. Therefore 25, because we have to find out distance now, that's why I'm taking D. Therefore 25 meter. So which is the right answer? Option C is the right answer. 25 meter. 25 meter. Okay, students, right? Okay, do you understand? Okay, the next Phillips. See the first one. Rapid back and forth motion of a particle about its mean position is called rapid back. Yes, rapid back mean position is called as what? Rapid back motion was called as oscillations. Right? Okay, next, if the energy is a longitudinal wave travel from south to north, then the particle of medium will vibrate in perpendicular direction. Perpendicular direction. Okay, right? Okay, next one, third one. A whistle given out of a sound of frequency 450 Hz approaches a stationary observer at the speed of 33 meter per second, and the frequency heard by the observer is, speed of sound is 330 meter per second. See this, that whistle give out of sound frequency 450 Hz, and the observer speed sound is 33 meter per second. We have to find out that frequency heard by the observer. Okay, so what is that answer? See this one. See, this is the answer. See this. The source is moving towards the observer. Source is moving towards the observer. N dash which is equal to V divided by V minus Vs. Vs for source into N. N is the frequency. Okay. V is the velocity of sound. So velocity of sound is given 330, and yes, source producing the frequency, normal frequency 450. Therefore, I am just substituting the values. 330 divided by 330 minus 33 into 450. Yes, I can get 330 into 450 divided by 297. Therefore, which is the answer? 500 hertz. 500 hertz. So what is that answer for third question? 500 hertz. Okay, do you understand? Okay, next. A source of sound is traveling with the velocity is for 40 kilometers per hour towards an observer and emits a sound of frequency 2000 hertz. Okay, and if the velocity of sound is 1220 kilometers per hour, then the apparent frequency heard by the observer is okay, right? Yes, what is the answer? See this. The condition for this one, frequency heard by the observer. Therefore, the formula is N dash which is equal to V divided by V minus Vs into N. So V is for source velocity. So V is given 2000 divided by 1220 minus 40 into 1220. Therefore 1220 minus 40, 1180. Therefore 2000 into 1220 divided by 1180. If I simplify, I can get N dash apparent frequency heard by the observer is 2068 hertz. 2068 hertz. So the answer for fourth question is 2068 hertz. Okay, students. Okay, right? Okay, and next, true or false? Listen carefully. True or false? Okay, first one. Sound can travel through solids, gases, liquids, and even vacuum. So which is this is the true or false? False. So first one is false. Okay, and second question, waves created by earthquake are infrasonic. Waves created by the earthquake are infrasonic. Yes, it is infrasonics, therefore true. Yes, true. Okay, the answer is true. Next, third question, the velocity of sound is independent of temperature. The velocity of sound is independent of temperature. That is false. So false. Okay, and next, last question, the velocity of sound is high in gases than liquids. The velocity of sound is high in gases than liquids. This is also false. Okay, so first one is false, second one is true, third one is false, and fourth one is false. Okay, students, right? Okay, right. And next, match the following. See this side. First one is infrasonic, echo, ultrasonic, high pressure region. This side, compressions 22 kilohertz, 10 hertz, ultrasonography. Just I'm matching. Infrasonic waves has frequency Yes, what is the frequency? See, 10 hertz. Infrasonic wave sounds are 10 hertz. Okay, and next, echo. So echo is used in what? Ultrasonography. Because used in ultrasonography. So second one is, this is ultrasonography. Okay, next, ultrasonic waves are having frequency, that is option B, 22 kilohertz. Ultrasonic waves has frequency 22 kilohertz. So for third, this is the option 22 kilohertz. And next one is high pressure region. So for this high pressure region, so the last one is compressions. High pressure region, compressions. High pressure region produce the compressions. Okay students, right? Okay students, today class is over. We'll see you on next class. Okay students, 1 marks is over. Okay, so fifth lesson is over. Okay students, okay, see you on next class. Thank you students.